Hello, my name's Gavin. In this video I'm going to be showing you a quick basic setup to perform your first initial AMI scans. For this demonstration I'll be using a typical plastic package device. In this case I'm going to be using this BGA device. So let's go ahead and start the software. So we're using a Sonoscan Gen6 system, and the software that runs the system is called Sonolytics. So double click, log on, OK. If this is the first time the system's been on, then it will perform a bed sweep routine like it's doing now. I've already gone ahead and pre-filled the tank with deionized water, and I filled it more or less to the top of the glass window on the front side. So the fixture I'll be using in this video will be the standard fixture with a glass plate bottom. There's two locations we can put this, either at the front of the tank or we can put it in the center. We'll put it in the center so it's nice and clear so we can see what's happening. You can release the glass plate to release any trapped air bubbles. Just put that back in, lock it back in place. Once the fixture is in, we can then install the transducer. So for plastic package devices, you'll be using between 15 and 50 megahertz. So we're going to start with the 15 megahertz transducer. This has a focal length of 0.75 inches. So go ahead and install the transducer. While the door is still open, we can go ahead and install the sample as well. I've got several plastic packages here, but we'll just use one for now, BGA device, and we'll place it in the corner of the fixture like this. So now the sample is in, we can close the door, security door. Here we can now see the software screens. The first thing we need to do is select the correct transducer. So let's go ahead and look at that. If we look at the RF interface, the window in the top left, and then we're looking for the transducer icon just on the left side there. Just double click that, or single click, and we can select the transducer we have fitted, in this case 15 megahertz 0.75 inch focal length. Okay. So now that we have the transducer installed and the correct frequency selected on the software, we can move the transducer over the sample, ready for scanning. This is a manual operation, and we'll be using the transducer control window on the right side of the screen. So we have a group of arrows here around the home logo, and this is for controlling the transducer in the X and Y direction. And there's two smaller arrows up and down on the right side. They're for controlling the focus, or Z axis, of the transducer. When clicking, you want to be using the right mouse button. If you use the left mouse button, it's just single step. Right mouse button is continuous movement. So I'm now over the sample and I start to see a signal, which is great. I'm more or less in the center. You can do it by eye as best you can. If you're used to the system, it's quite easy, but if you prefer to use the automatic method, we can do that as well. So back to the transducer control window, we have an icon that looks like an eyeball. So if we click this, you do have to be over the part first before you click this and have a valid signal, which we do, so we can go ahead and click that. And in this case, the transducer will move to each of the sides and calculate the scan size and the center of the device at the same time. So now we have the transducer perfectly in the center of the sample, and this is what we call the home position. So every time you stop a scan, it will return to the home position, center of the sample. So if we just return to the software screen, okay, there are 5 steps that we need to run through before performing our initial scan, and we'll run through those now. The first 3 steps will be your focus, your gate position, and gain adjustment. Focus, gate, gain. So focusing the transducer. We're going to be making 2 scans of this device. The first scan is going to be of the top surface. The second scan will be the internal interface scan. So we need to focus on the top surface to make the top surface scan first. If we turn our attention to the RF interface again, and we can see the signal, the first echo that you see at 0 on the left is always the top of the sample. So that's where the software does all its triggering, all its timing from, is the first thing we see, or the software sees, is the top of the sample. So that's the echo we need to focus on. So back to the transducer control, and we're using the up and down arrows, and you can see the signal changing amplitude as we drive up and down. So we're looking to maximize that echo, and then it's focused. That's now maximized and now focused. Perfect. Next, the gate position. As we want to image the top surface, we want to put the gate over the top surface echo. That's a bad position. That's a bad position. You want to include the complete waveform of that echo as a good starting point. So that's the focus, the gate. The third thing is adjust the gain. So the gain control is this second sliding bar here on the RF interface. The right side, or the green one, is the secondary gain. We're just going to be using the front end gain. Typically you're not adjusting this one unless you're using 2 channels, doing through scan, or doing using extra options that we're not using right now. So for now, just use the front end gain adjustment. So what you're looking for is to adjust this until the semi-scan scale, which I'm about to show you on the right side here, is around 60 to 70%. I've got it on 66. So you want to adjust that until that's around between 60 and 70%. Is a good starting point. Excellent. The final 2 things we need to do now is determine the scan size and image resolution. So back to the transducer control window on the right side. When we did the find part option, which found the center of the part, it automatically calculated the scan size for us at 29.3 millimeters. Let's make it a bit bigger. Let's go with 35 millimeters. So we enter that in. When you enter your scan size, it will give you a default range of pixel pitch on the left. So in this case I have now between 3 and 136 microns per pixel for my final image. As is just my initial scan, I'm going to go with the maximum 136 microns. So I can now start the scan. So the start scan button is just here. And that will start to build the image line by line. From this image we can, even though it's not an internal scan, we can get a lot of information from it, such as the moulding mark. We have the laser marking and any imperfections that might be on the top surface we can see and record as that as well. So let's go ahead and save that. File, several save options. The first one will be saving in the Sonoscan format, which is image and parameters. The subsequent options are saving in bitmap, JPEG, PNG type format. I'm just going to go with the top option for now, and I'm saving all my images in a folder called Basic Setup. This one's going to be BGA top surface. I also like to put the frequency that I used for reference, and also the pixel pitch. 136 microns pixel pitch. Caps lock on. Pixel pitch. There we go. Save. So that has now saved. I have to go back to it. We saved it in IMWX format, and that's the Sonoscan format, which contains the image and parameters. You can convert that to bitmap or JPEG later if you wish.